Okay, good afternoon. Welcome to the BA 215 Hence Using Technology in Business Statistics webinar. Actually, this webinar today, we're going to start with a different topic. We're going to be talking about how to work through some of the problems that are asked of you in your weekly assignments. In particular, this week, we're going to talk briefly about using the statistical process. Now, if you read through your book, statistics has four different components, and the first part is collecting the data, organizing, summarizing, and then analyzing data. And the reason that we do this is because we want to answer questions or draw conclusions uh, about some data. Data meaning information that we've collected. So basically, statistics is about data, the science of data. Now, there's a process to statistics, like I said previously. There are four steps to it, but in more detail, we can talk about the process. The process is first to identify what is our objective. What is the researcher trying to find out? After they have identified the objective, then they need to collect information in order to answer the question that they have posed in the first step. Thirdly, after they've collected all the data, they have to organize this data and then summarize the information that they have found. Now, this summarization is also called descriptive statistics, and we're going to talk about this in detail a little bit later. The fourth step is talking about the conclusions that we can draw from this information. And these conclusions most times are referred to as inferential statistics. Inferential statistics. So for today's webinar, we're going to focus on step 3 and step 4, the differences between descriptive statistics and inferential statistics. On the screen, I have the definition of descriptive statistics and inferential statistics. Now, descriptive statistics is basically just organizing and summarizing what data you have on hand. Inferential statistics, though, is a process where we take the data that we have looked at. Most of the time, the data that we looked at is just a sample of the population, and based on this sample, we make generalizations about the entire population. Now, the latter, is referred to again as inferential statistics, and you can focus on the beginning inferences. We're making inferences or educated guesses about an entire population based on a sample. Now let's look at the example on the board, on the PowerPoint. So we have a researcher who is conducting some research based on the population of Americans that are 18 or older, and she gets from the population a sample of 1,100 Americans, adults. Now, she who is she? Who is this researcher interested in researching? She wants to find out information about all Americans, but there are 330 million Americans. Of those 330 million, I don't know how many are age 18 or older, but it's a huge number. Now, it's impossible or nearly impossible, unless it's a survey, to get information from every single adult in America. So, what she does is she gets a sample. Now, she takes a sample of 1,100 Americans and she gets information from this sample. The information she gets from the sample is called descriptive statistics. The information she gets from the sample is called descriptive statistics. Now, after she gets this information from the sample, she wants to make a generalization about the population. So she can say, now, for example, the average age of the sample was 35. The average age of the sample of 1,100 was 35. So she can say, well, based on the sample, I can say that the average age of all Americans, adult Americans, is 35 years old based on the sample. And this generalization to the population is referred to as inferential statistics. Now, what we're going to do are a few problems to help you understand this. There are two simple problems and then one pretty complicated problem, but the objective is the same. We're going to do 4 steps. The first is to identify the research objective. What is it that we're trying to figure out from the problem, from the research? And then identify who is in the sample, the descriptive statistics, and then the inferential statistics. Okay, so 4 parts. Let's start with example number 1. Now, in example number 1, you can read along with me. It says that Gallup News Service, which is an organization, conducted a survey of a little bit more than 1,000 American adults that were 18 years or older, and they conducted the survey in 2004. At that time, they asked the 1,000 adults, 1,003 adults, how many movies they have seen in a movie theater in the past 12 months. So in the year of December, how many times had they gone to a movie theater to see a in the year of 2004, I'm sorry. In the year 2004, how many times had they gone to a theater? And of the 1,003 that were surveyed, a little more than 650 said that they had gone to see the movies at least once in the past year. 65% of all Americans in the survey. So based on that, the Gallup News Service said, well, then if the survey has 65% um, going to the movie, seeing at least one movie in a movie theater in the past 12 months, then we conclude that 65% of all Americans are this way. So let's see then. Remember, we are trying to find the research objective, the sample, the descriptive statistics, and the inferential statistics. Let's see them. So first, the research objective. They want to know how many times have adults in the US gone to the movie theater in the past 12 months. That's the objective. The sample is 1,003 US adults. Descriptive statistics. What is the information that we get from the sample? This is descriptive statistics. Based on the sample, 65% have attended a movie at least once in the past year. Now, inferential statistics, this is not just the sample. This is all Americans. So based on the sample, we can say that all Americans, adults, 65% of them have gone to see a movie in the past year. This is in 2004. Okay, so this is pretty simple, right? What's the difference between descriptive and inferential? Descriptive is based on the sample. Inferential is based on the population. Let's go again. Morally acceptable. This again is taken from a few years ago, maybe 10 years ago. The survey asked 1,000 adults in America if they believed that it was morally acceptable to have a child outside of marriage. And they surveyed 1,000 adults. Of the 1,000, 49% said it was okay. Now, based on this, they concluded that 49% of all US adults thought it was okay to have a baby outside of marriage. Now, let's go ahead and find the the research objective, the sample, the descriptive statistics, and the inferential statistics. The research objective is that they are trying to figure out what percent of Americans think it's okay or not okay to have a baby outside of marriage. That's the objective. The sample is the 1,000 US adults. The descriptive statistics is based on the sample, and it says 49% of the 1,000 believe it's acceptable to have a baby outside of marriage. And then inferential, again, talks about the entire US population. So not just the 1,000. Based on the 1,000, we can make assumptions about everybody. Now, um, the last example that we're going to look at is this one a little bit more complicated. It's talking about music. Now, there's a lot of verbiage in this problem. They are trying to figure out, though, essentially, whether or not listening to music can affect your math and spatial reasoning skills. So, if I listen to music first and then I take a math test, will that improve my score or will it have no effect? If I take a spatial reasoning test after listening to music, will it improve my score or will it have no effect? So, what they did is they gave 36 college students, um, they separated them. Oh, I'm sorry, they didn't separate them. They have 36 college students and they gave them two tests. The first time they allowed them to listen to Mozart classical music for 10 minutes, and then they gave them the test. Then they were asked to sit for 10 minutes in complete silence and then take a test. Now, those that the t- so they have the same students, so they want to know whether or not the music affected them. Now, the research objective, again, is to determine whether or not music affects your test score or specifically your mathematical or spatial reasoning. And then what they used for the sample was 36 college students. The descriptive statistics, it says for the 36 college students, the average score was 119 after they listened to the classical music. But when they didn't listen to music, the average score was 110. And this is based only on the college students. Now the inferential statistics says, okay, this worked for the college students, so we are going to say that it works for everybody. And so they concluded that if you listen to music before taking a spatial reasoning test, your subject will your score will improve. So again, this one's a little bit different from the ones that we did before. The descriptive statistics talks only about the college students, but the inferential statistics, they actually applied it to anyone that's taking a test in this particular problem. Okay, so hopefully this explains a little bit the difference between descriptive and inferential statistics. If you have any questions, please don't hesitate to contact us in the Math Center, and we can arrange for someone to work with you one-on-one. Enjoy your day. Goodbye.